Learning never stops. Words of Captain Joseph Horn, Commanding Officer USS Lake Erie CG-70, said at the conclusion of the Aegis BMD Stellar Dragon campaign in March 2005.
The confidence that is built with the knowledge that is learned, it's a continually evolving process that gets us better and better and better.
Achieving 5 out of 6 ballistic missile intercepts over 3 years of testing with the sea-based element of the Ballistic Missile Defense System, Aegis BMD, the Missile Defense Agency, MDA, Navy, and the Aegis BMD test team aim to learn and improve from what is arguably their most challenging test to date, the engagement of a separating medium-range ballistic missile target off Hawaii over the skies of the Pacific Ocean in Stellar Valkyrie, FTM 04-2. The objective of Stellar Valkyrie, also called FM-8, for Lake Erie and its crew, is the continued testing of the Aegis BMD Block 04 initial ballistic missile engagement capability. Conducted in 2 phases, a preparatory tracking exercise leading up to a flight test, accomplished by achieving a lethal intercept of a Group B medium-range ballistic missile target called an MRT. Significantly, the MRT is a multi-stage separating target with a booster and re-entry vehicle, the first such engagement attempted by Aegis BMD using its SM-3 missile. Previous tests have been against unitary, non-separating ballistic missile targets. With Aegis BMD testing in full swing, a lot has happened since the conclusion of the Stellar Dragon campaign in March 2005. In Moorestown, New Jersey, Aegis Combat System Engineering Agent for the Navy's BMD Program Office, Lockheed Martin, coordinates activities across the Aegis BMD team to ensure the success of the flight test. Large amounts of data are analyzed from Stellar Dragon and an April tracking exercise using an MRT, the same target used for the flight test. Lessons learned have gone into the development and testing of the latest Aegis BMD weapon system configuration. Using this configuration, the first Block 04 Aegis BMD cruisers add short and medium-range ballistic missile engagement capability to the current Aegis BMD long-range surveillance and tracking mission. These Aegis BMD cruisers are available for emergency activation if called on. Development and testing of the Aegis BMD weapon system configuration continues at Lockheed Martin's Computer Program Test Site. Here, Lockheed Martin engineers work with programmers from Computer Sciences Corporation, CSC, in Moorestown on Aegis BMD Block 04 computer programs. Integrated testing of the Aegis BMD weapon system takes place at the Navy's Combat System Engineering Development Site, CSEDS, in Moorestown. In the mini-suite, Lockheed Martin and Naval Surface Warfare Center Dahlgren engineers thoroughly test the Aegis BMD combat system. Testing demonstrates the effectiveness of human-machine interfaces, equipment, and computer program modifications to the Aegis weapon system, supporting Aegis BMD long-range surveillance and track, LRS&T, and ballistic missile engagement capabilities. In addition to this testing, extensive analysis and planning go into developing each Aegis BMD test scenario. With the first use of the separating MRT target, hundreds of simulations of the Aegis weapon system using Lockheed Martin's Medusa program are run. This is to predict and verify a firing solution for Aegis BMD capability against a potential class of ballistic missile threats, including this test scenario. In Tucson, Arizona, Raytheon's Missile System Division conducts its own missile performance analysis, as well as continuing the testing and development of the SM-3 missile with its kinetic warhead, or KW. The SM-3 missile is now under production in the Block 1 and 1A configurations. SM-3 Block 1 missiles are ready for installation in designated Aegis BMD-equipped cruisers, adding a sea-based ballistic missile engagement capability as part of the initial Aegis BMD role. The FTM-04-2 flight test is the second use of a production SM-3 Blk I missile in a test event. In Laurel, Maryland is the Johns Hopkins University Applied Physics Laboratory, APL. APL is the technical direction agent for the Aegis BMD program, providing technical assistance for the Aegis weapon system and Standard Missile 3 development and testing. Inside APL's Guidance System Evaluation Laboratory, Gazelle, engineers evaluate SM-3 missile functionality using actual flight hardware and software. High-fidelity testing validates that simulations accurately predict Aegis BMD system performance capability to close the fire control loop. Working closely with the rest of the Aegis BMD community, APL conducts this testing, increasing confidence in flight test success. At the Naval Surface Warfare Center in Port Hueneme, California, Aegis BMD team members, military, government, and civilian, meet at the Mission Control Panel, also called the MCP, assessing mission readiness issues and preparatory status. Speaking about the challenges of the test, Rear Admiral Kathleen Page, the former Aegis Ballistic Missile Defense Program Director, opens the MCP.
Remember, we're about results, not rhetoric. And so as we go through this Mission Control Panel, for firing mission number 8, all the way through target launch, our objective collectively and for each and every one of us is to get to the point where we will be able to look Admiral Meyer in the eye and tell him, as of T = 0, we did everything we knew how to do to make this firing mission a success.
After presentations and deliberation, the test is approved to proceed. The first flight test against a medium-range separating target is on. During October, Lake Erie, its crew, and the Aegis test team prepare for the flight test in Pearl Harbor with a series of in-port waterfront integration tests. Used during these tests is the Dockside Simulator, a portable version of Lockheed Martin's land-based Aegis Combat System Interface Simulator, AXIS. AXIS supports Aegis BMD tactical weapon system training for Navy personnel at the waterfront, especially important for simulating a realistic MRT separating ballistic missile. The Dockside Simulator injects simulated ballistic missiles called dynamic test targets into the SPY-1 radar computer program. This provides threat scenario representations with objects of varying radar cross-sections representing potential targets. Lake Erie systems are checked out. Test equipment is installed, including the telemetry data acquisition and analysis shelter, the virtual operational missile, video and photographic data collection equipment, and weapon system data analysis workstations. And officers and crew continue their training. Of particular importance is the system integration and installation of the latest Aegis BMD Blk I weapon system configuration, used for the first time as part of the continuing development of Aegis ballistic missile defense engagement capability. Before the flight test begins, a sea trial takes Lake Erie out to the Pacific Missile Range on a tracking exercise. An ARAV-B ballistic missile vehicle having similar characteristics to the MRT is used for the TrackX. Joining Lake Erie are Aegis BMD-equipped ships Destroyer USS Hopper DDG-70 and Cruiser USS Port Royal CG-73. Port Royal, like Lake Erie, is operating the new Aegis BMD weapon system configuration. It's also here to conduct a simulated SM-3 engagement against the ARAV-B. Port Royal and Hopper have no test equipment or Aegis test team members aboard. Instead, accompanying these ships are members of the Navy's Operational Test and Evaluation Force, OPTEV-4, providing an independent and objective evaluation of the operational effectiveness and suitability of Aegis BMD. Hopper is one of the most recently converted Aegis destroyers with Aegis BMD long-range surveillance and track, LRS&T capabilities. This provides the opportunity to conduct operational evaluation of a destroyer using the Aegis BMD LRS&T configuration. Stellar Valkyrie testing continues the objective of demonstrating operational realism used during the Stellar Dragon campaign earlier in 2005. All three ships operate in a war cruise environment with an intelligence overlay for all events. Intelligence from 3rd Fleet Commander assigns Lake Erie, Port Royal, and Hopper the mission to perform surveillance on Country Red's radical regime and watch for a launch of a ballistic missile near friendly Country Green. First demonstrated during the Stellar Dragon campaign, the ships use Mission Planner, the automated mission planning function, which assists the radar systems coordinator in developing Aegis spy radar search doctrine and setting up search sector parameters to prepare for a potential ballistic missile launch. On the Pacific Missile Range Facility launch pad is an ARAV-B ballistic missile, a Terrier Oriole Group B threat representative test vehicle. Positioned more than 350 miles from Country Red's missile launch facility are Lake Erie and Port Royal. Each is traversing within an assigned operational area. Positioned closer to Country Green's defended areas is Hopper. Hopper is conducting an LRS&T mission. Officers and crews of the ships, working from an intelligence overlay and as part of their training, know potential launch sites and enemy order of battle, but don't know the precise hostile ballistic missile launch time. They wait, ready to detect, track, and perform a simulated SM-3 engagement, also passing target information to other BMDS elements. The ships detect the ARAV-B ballistic missile at about the same time as it enters the radar search sector with their Aegis Spy 1 radars. The ARAV-B is a separating ballistic missile, like the MRT, scheduled for the flight test. These separating targets are a greater challenge for Aegis BMD, since they present a smaller radar cross-section to the Spy 1 radar. For a successful engagement, Spy 1 must keep the ARAV-B in track and identify its parts after separation.
All stations, Captain. Batteries released. Fizz is green.
Attack control. Killing track 1000 Eagle.
3, 2, 1. Fire authorized. Eagle away. Track 1000.
All stations, TAC Fizz ready.
Time to intercept 4 or 5 seconds. Mark India. Track 1000.
The Aegis BMD team and Lake Erie uses the TrackX exercise to verify Aegis BMD crew, ship, and combat system readiness before the flight test begins. TrackX also verifies ARAV-B vehicle performance characteristics. Aboard Port Royal and Hopper, OBTEV-4 evaluates officers and crew operating Aegis BMD and how the ships perform against the ARAV-B. In addition to the Aegis BMD ship's participation in TrackX, other assets are involved, tracking and gathering test data during the TrackX. Tested with Aegis BMD is the Transportable Radar Sensor Experimental, or TIPSY-X, an X-band radar prototype for the THAAD weapon system, collecting data to support BMDS forward-based radar development efforts. Another objective of these tests is to verify Aegis BMD tactical voice and data communication links. TrackX uses Link 16 with the Aegis BMD ships, sending and receiving data with other ballistic missile defense system elements, and testing voice as well as data communication links. Lake Erie and Port Royal fire no live SM-3 missiles, but conduct simulated SM-3 engagement processing against the ARAV ballistic missile. Operating in a war cruise environment, they successfully detect and track the ARAV-B, gathering data and exercising BMDS operational communication links in an Aegis BMD weapon system engagement configuration. With Track X over, the ships head back to Pearl Harbor. From here, Port Royal proceeds on duties assigned, while Lake Erie, Hopper, and the Aegis BMD test team arrive in port. For the next 2 weeks, the Aegis BMD test team reviews ARAV-B Track X results.
We had a great week, I think, operationally at sea. From the engineering perspective, it was an opportunity to get underway and track the ARAV-B target to ensure that we had the results of the systems integration tests and all the engineering runs that we had done heretofore were correct, and we were able to go for mission day.
Before departing Pearl Harbor, Lake Erie stops at Weapons Station Naval Magazine, Pearl Harbor. Here, an SM-3 Blk I is loaded into a cell of the aft Mark 41 vertical launching system. Inside this canister is the fleet-ready SM-3 missile that will engage the MRT during the firing event. There are only 3 days until the flight test and completion of Stellar Valkyrie. On November 14th, Lake Erie departs Pearl Harbor with its crew and members of the Aegis BMD team for another ballistic missile defense flight test, FTM 04-2. Lake Erie transits further than ever before to reach its test operational area. This is because of the longer range of the MRT ballistic missile target. With Lake Erie as Aegis-equipped destroyer USS Hopper DDG-70, participating for the first time in an Aegis BMD flight test. Hopper is one of a growing number of Aegis BMD-equipped destroyers at sea and alert-ready today, providing LRS&T capabilities back to other BMDS elements, acting as a remote BMDS sensor. Hopper's mission is to gather test data and exercise its surveillance and tracking capabilities against the MRT, using its Aegis BMD LRS&T configuration. After detecting and tracking the MRT, Hopper will transmit this data over link 16 back to other BMDS assets. At their battle stations in the early morning hours are the officers and crew assigned to in-service Navy combat ships USS Lake Erie and USS Hopper, who will execute the flight test. Continuing the test objective of operational realism, the ships receive an intelligence report from Commander 3rd Fleet to perform active BMD defense of ally country Green. Both Lake Erie and Hopper are maneuvering in their assigned operational patrol area. Their crews are at space warning condition yellow readiness, awaiting a hostile ballistic missile firing. For the flight test, Aegis Auto BMD Doctrine missile engagement is used. With Auto BMD Doctrine, the Aegis system automatically computes a recommended time to fire and engage the target with an SM-3 missile. Aegis can fire the SM-3 automatically, but as part of the firing loop in this test, the Aegis BMD system will alert the Missile System Supervisor, MSS, when to press the fire key. After a series of increasing threat levels, Lake Erie and Hopper receive their latest intelligence reports. Set space warning red, weapons tight. They are at the highest state of alert for a ballistic missile launch. They get no target launch countdown. They must be ready to react to hostile actions and detect a threat launch. Knowing where to direct Spy 1 radar search volume is important for early target detection. Lake Erie's radar systems controller uses Mission Planner, the automated mission planning function, to help set up the ship's Spy 1 radar search doctrine and search sector parameters within the operational area. The engagement against the MRT is the longest range attempted to date by Aegis BMD. Inside the MRT is a simulated threat payload, the target for Lake Erie's SM-3. With this operational test scenario, it will take about 6 minutes from the time the MRT is launched before the SM-3 can reach and destroy its ballistic missile target.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mark, target is liftoff.
A side-mounted video camera on the MRT provides a real-time view as it climbs above the atmosphere and into space. Aegis Spy-1 radar on Lake Erie and Hopper detects the target as it enters the radar search sector. During the flight of the MRT, the re-entry vehicle separates from its booster.
Coming. That's him.
Fireball, 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 track number 3007.
Seconds later, Hopper transmits the MRT track data over Link 16 back to the Ballistic Missile Defense System, BMDS.
This is Hopper. Launch confirmed. Target is other.
Tech control, auto engagement ordered. Battle short enabled.
After the set space warning red weapons free is announced, Lake Erie's commanding officer authorizes the vertical launching system in preparation to fire.
All stations, Captain Fizz green. Clear to fire.
Tech control, killing track 3005 Eagle.
Spy-1 radar transitions to target track and distributes information to the Aegis weapon system. Spy-1 radar processing determines that the target is in its ballistic flight phase, and the Aegis system declares the MRT track as engagement quality. Now, Spy-1 identifies the re-entry vehicle.
That's him.
Aegis processes the target automatically for engagement in the auto BMD mode and initiates the engagement order to the Missile System Supervisor, or MSS. Upon receiving a recommend fire alert, MSS presses the Fire Authorization Variable Action button.
Fire authorized. Eagle away, track.
Shortly after SM-3 launch, the Spy-1 radar system acquires and tracks its SM-3 missile.
All stations, Captain Fizz red.
Control eye.
The Aegis weapons system continuously updates its precision fire control solution to engage the target. Acceleration commands computed by the Aegis weapon system are transmitted to the SM-3 missile via spy radar uplink message data, keeping it on a target intercept path. After second stage burnout and separation, the Aegis weapon system updates the SM-3 with both its and the target's position and velocity data. With the longer MRT flight path, the Aegis weapon system gives data commands to the SM-3 missile to perform 2 sequential pulse burns with only a small delay between pulses. This is the first time in a flight test the SM-3's third stage rocket motor, TSRM, executes a burn-burn ditch. After the second TSRM pulse burn is complete, while coasting, the missile performs a pitch maneuver, safely ejecting the nose cone while maintaining a collision course on the target. The third stage attitude control system orients the missile so that it points at the target. Before the KW is ejected, the Aegis system gives Phase 3 uplink information to the TSRM, providing Aegis target and object track data to the SM-3. With spy radar accuracy, the Aegis weapon system is able to put the target dead center in the SM-3's field of view. In this animated view of the closing sequence, the KW acquires the MRT after ejection from the third stage. The KW, using its infrared IR seeker, correlates its tracks to those received from Aegis to distinguish the target from other objects, quickly driving the KW to the target with divert guidance. A square around the target image indicates that the target is in track and KW divert guidance has commenced. A direct target hit. The target is destroyed. The KW intercepts the MRT at the desired aim point. An impressive history-making event for Aegis BMD. Its 6th success out of 7 firings. The test provides an important data-gathering opportunity with a variety of optical sensors and radar systems observing FTM-04-2. Sensors clearly show the lethal MRT destruction by the Aegis SM-3 missile. This is a slow-motion Halo 2 airborne system recording of the KW target impact, showing the SM-3 third stage, its nose cone, and the KW. Here is the MRT. These images show the KW impacting the target with its simulated threat payload. Lake Erie uses the Aegis BMD kill assessment capability and missile downlink system testbed to evaluate its intercept success. A live video conference link between Lake Erie, EMRF, and other Aegis BMD sites allows the MDA community and guests to witness the success. The team is ecstatic and proud of the test results they see and know the path ahead has even greater goals than the first MRT intercept.
Missile defense is a tough business, as we all know, but together, there's nothing that we can't accomplish.
We took a capability to sea in an operational, realistic scenario. We tracked a realistic threat-like object, and we engaged it successfully.
But the MDA, Navy, Aegis BMD team is ready for the challenge, making the previously impossible possible, guarding our nation, our armed forces, and our friends. We're Aegis Ballistic Missile Defense, and we deliver again.